In the previous tutorial, we created our preliminary set of tables. Now the hard work begins. Now, to the untrained eye, you might look at this set of tables and think that everything is absolutely fine. Looks like a good set of tables. We have a product name, description, and type. We have a product line, the price, the image, and so on. And we have a category, the category name. So let's go through a process where we try to identify any multi-valued fields. So a multi-valued field is where potentially a field would store more than one value. And that is something that we want to avoid within our database. So we want to remove any multi-valued fields and then perform a certain range of actions on those fields to resolve the problem. So the first thing that we can do is let's take one of our tables. In this case, this is the product line. And let's just lay it out in a table as if it were in a database. And let's add some data. And by doing that, what we have found from this is that there are some multi-valued fields. So here we have one entry within our product line table. Here we have the product price. No problem. It has one price, of course, although it may have multiple prices. For example, sale price, but that would probably be in a different field. Then we have the product image. So in actual fact, one product line item may have multiple images. So here we have a multi-valued field. So that's something that potentially we need to deal with shortly. In addition to that, at the back end here, we have product color and product size. Now we know that this product here, if we think about this as an individual product, then potentially it would only have one color, maybe in one size. But for the sake of this particular scenario, what we're going to say here is that in this product line here, this product line may have multiple colors. So you can see that potentially here, the product color and the product size, there are also some multi-value fields that we need to resolve. So the first approach to resolving this is that we can add those fields into multiple lines. So we just simply duplicate the data, and for each entry within our database, we just change the product image. So what we have is the same product in our product line 3 times, but here you can see the data is slightly different in the product image. So that's one approach. Now you can see here, this approach is going to generate a lot of redundant data. And what I mean by that is that there's a lot of data that's repeated. So this is just one product ultimately, and we're having to generate that 3 times. So the price, the product SKU, quantity, and the colors and so on, which is ignore for now. You can see that that has to be generated 3 times. And that's going to take up a lot of data in your database, and potentially that's going to cause issues. One of those issues might be update anomalies. So for example, if we were to update how many, for example, products we had of this particular product here, potentially that would also affect these other lines as well, because they are the same product, they just have different images. So we would actually have to update all of these different products here at the same time, and that can cause problems. Redundant data in general in our database is what we're trying to avoid. And the whole point of designing our database is so that we only have to enter the data once in our database. So the second approach is we can flatten our table in terms of adding more fields. So you can see in this case, we have one entry here, which is the product again. And instead of having individual rows for the image, we simply just add new fields for the different images. So image A, image B, and image C, for example. In some cases, this could work, okay? If you have some very static data, which you know will always require 3 images, then potentially this could be a way of working. But we can see here that, for example, if we added some more products, for example, a product might not require 3 images. And in some cases, we may want to add more than 3 images. So then we have a problem because we only have fields for 3 images. So you can start to see that there are some problems there in terms of inserting a new product line which has more images. But in addition to that, we have these null values, these empty cells here. And that's something else that we want to try and avoid as much as possible when we're developing a database. We want to avoid having these empty cells. So this approach isn't necessarily the best approach in this scenario. Ultimately, what generally happens is that we remove the field from the table and we create a new table with this data. By doing this, in actual fact, it kind of makes a little bit more sense because we work out, in actual fact, that the image potentially is something that we want to model, is something that we want to store information about in its own right, its own subject, its own entity. So what we can do here, for example, is generate a new table. And then if we just intuitively think about what other attributes an image might have, we have an image name, we have an alternative text. So for example, that can be utilized on the page for accessibility needs. And then we have the actual image location where we can actually find the image and then retrieve it and then send it back, in this case, to the front end. So that's the general process that we're going to take when we find any multi-value fields. We simply just go ahead, create new tables, and utilize the information that we've extracted from the initial table to create our new table. So a quick update then of all the tables that we have generated now through this process. We have the product line. Now we have removed the product image from the product line now. So we've created the product line table and the category and the product table. So although this isn't necessarily entered correctly, this is really just to demonstrate the point. What we have now in our product line table are these two multi-value fields here, the product color and product size. Now, these are essentially, if we were to summarize these are attributes. So have we just found a new subject that we need to store information about? So because they're multi-valued fields, we're going to extract here and we're going to add into a new table called attributes. So we extract the information, and what we need to store in our attributes table is the attribute name and the attribute value. Now we need to perform the same task or the same action on this new table. So let's go ahead and add some data, and what we find is that we have another multi-valued field here. So this is the attributes table that we just generated. Here we've added some data, so for example, the color and the size. And notice here we have multiple values here in the color and the size. So potentially what we need to do now is extract this multi-value field here into its own table. So I'll go ahead and create a new table, attribute value field. And we have a new column here, red, blue, and yellow. And now what we have is a table that doesn't have any multi-valued fields. So now we have an updated table list. This time now we've added the attributes table with just the name. And now we have the attribute values. We have a field at the moment, we've named that attribute value. So here's a checklist which you can utilize for your fields to determine whether you have generated a good field or not. So does it represent a distinct characteristic of your subject of the table? Does it contain only a single value? So that's something that we've been exploring. It cannot be deconstructed into smaller components. Unfortunately, there wasn't an example that we could work through. So let's just imagine we had a person table. This table would have many different fields, for example, the name, age, address. Now with the name, let's just think about that for a minute here. The name or person's name, they have multiple components here. We have the first name, we have the middle name, and then we have the surname. So potentially, if we had a field just called name, then this would be a field potentially that we would need to split up into multiple fields. So that's what we mean by, can the field be deconstructed into smaller components? So some fields will, for example, we could do the same thing with an address. So we have the number of the house, we have the road, we have the general location, and then we may have some unique number which represents that location. So that's another example where we might want to split up that data. Something else that we want to try and avoid is having data within our database that is calculated or is derived from other values within other tables. So we want to try and avoid that. So our table shouldn't contain any calculated values. And then last of all is a unique characteristic. So we don't want to have two names, for example, with two field names called name, for example. So we just need to make sure there aren't any duplicates, and that we are utilizing fields within our table that are clearly identifying a unique characteristic. Sometimes we may have fields that are very similar or have the similar information, so we can go ahead and merge them. Now, by all means, you can go ahead and look through all the tables that we've generated so far, have a look at all the fields and see if they meet our requirements in the field checklist. In addition to looking and checking the fields, we can also check the tables against this list. So let's make sure that our tables represent a single subject, that it doesn't contain any multi-valued fields, doesn't contain any calculated fields, as I've just explained, and does not contain any duplicate fields. So we also want to make sure that we try to keep redundancy. So that's where we have, for example, data stored more than once within our tables. We want to try and keep that to a minimum and avoid it if possible. So I do recommend, as we move through this course, that you think about making some changes in the data set here and maybe add a different table if needed, or add some different fields. And by doing that, not only are you just copying maybe what we're doing step by step, but you're also then kind of taking in that information and applying it as well into your own scenario. And hopefully you'll get a deeper learning experience by doing that. Although you may have problems and it may cause errors and problems, it may be harder to do so. I think ultimately that may give you a better experience.